Good morning, sir. My name is V. Saitya from third year Triple E department. My roll number is 23951A0221. Subject electrical drives and static control. Subject code AEE D26. AIT topic design a synchronous motor drive for constant speed operation in power plant auxiliaries. Topic is synchronous motor drives for power plant auxiliaries. Precision is constant speed. The unseen powerhouse by auxiliaries demand precision. Power plant relies on auxiliary systems, pumps, fans, compressors, and ventilation equipment for continuous uninterrupted operation. These critical systems require high reliable constant speed drivers to maintain optimal processor. Failure of speed fluctuation in auxiliaries can trigger costly down, hazardous and cascade throughout the generation. Power plant relies on auxiliary system, pumps, fans, compressors, and ventilation equipment. For continuous interrupted system requires highly reliable. It requires more power to operate. Like failure or speed fluctuation in auxiliary can trigger costly down, hazards and cascading. Synchronous motor, the heart of constant speed. Synchronized operation, the speed directly locked to AC supply frequency, ensuring precise, unvarying rotations. Load independent. Unlike induction motor, speed remains constant regardless of load variation once synchronized. Perfect for precision. In her characteristics makes them ideal for application demanding unvarying speed accuracy. These three are the synchronous motor, the heart of constant speed, synchronized operation, speed directly locked to AC supply frequency, ensuring precise, unvarying rotations, load independent, unlike induction motor, speed remains constant, regardless of load variations when synchronized. Perfect for precision. Inherent characteristics makes them ideal for application demanding unvarying speed accuracy. These are the synchronized motors, the synchronous formula. They were rotor and stator magnetic locks, field locks in perfect step, ensuring constant rotational speed. This magnetic interlocking creates robust, stable operation that essential for critical applications. Synchronous speed 120 F by P. F is the frequency, P is the number of poles, where F is the supply frequency and P is the number of poles. This is the formula for the synchronous to calculate the synchronous motor speed. Rotor and stator magnetic field locks in perfect step, ensuring constant rotational speed. This magnetic interlocking creates robots stable operation that essential for critical applications. Ns is equals to 120 by 120 F by P. Synchronous speed RPM 120 into frequency by number of poles, where F is the supply frequency and P is the number of poles. This formula is used to find the synchronous speed of the synchronous motor, ensuring constant rotational speed. This magnetic interlocking creates robots stable operation that is essential for critical applications. Powering the plant. Key applications in auxiliaries: pumps, fans, compressors, high power drives. Circulating cooling pumps, circulating cooling water, fuel, oil, condensate, and chemical dosing system requiring precious flow rate. Fans, forced draft, induced draft, and ventilation system maintaining combustion air and cooling flows. Compressor, air compressor, pneumatic systems, instrument airs, and process gas compression. High power drives, low speed, high torque applications where efficiency and reliability are absolute. These are the Key points for the powering the plants. Key applications in auxiliaries. Pumps, fans, compressors, high power drives. Circulating cooling water, fuel oil, condensate and chemical dosing system requiring precious flow rate. Fans, forced draft, induced draft and ventilation system, maintaining combustion, air cooling, air cooling and cooling flows. Compressors, air compressors for fencing pneumatic systems, instrument air and process gas comparisons. High power drives, low speed, high torque applications where efficiency and reliability are absolute. High power drives are mainly used in the cranes, elevators, lifts, etc. Pumps used in the coolant for the synchronous motors. Fans. In the power plant, we can see the forced draft and induced draft. To to burn the coal, forced draft fans are used and induced draft fans are used for to exhaust the gases from the boiler and ventilation system, maintaining combustion air and cooling flows. Compressors, air compressors for pneumatic system, instrument air and process gas compression. High power drives, low speed, high torque applications where efficiency and reliability are absolute. Modern control beyond the fixed frequency. Traditional fixed frequency, historically operated at constant speed, synchronized to grid frequency. Variable frequency drives. Modern VFDs enable flexible speed control while maintaining the synchronization. In the VFDs, we can vary the frequency according to our requirement. Advanced control architecture, vector model predictive control, VMPEC, enhanced obtuse against parameters mismatches. Optimal multi-objective control. Recent research Nature 2026 focuses on PMSM drives optimization for efficiency and stability. Modern control beyond fixed frequency. There are four modern control beyond fixed frequency. Traditional fixed frequency, variable frequency drive, advanced control architecture, optimal multi-objective control. Traditional fixed frequency, historically operated at constant speed synchronized to grid frequency. Variable frequency drives. Modern VFDs enable flexible speed control while maintaining synchronization. Advanced control architecture. Vector model predictive control VMPC. Enhance robustness against parameters mismatch. Optimal multi-objective control. Recent researchers Nature 2026 focuses on PMSM. These motors are mainly used in EV vehicles, EV cars and EV commercial vehicles. PMSM drives optimization for efficiency and stability. Advantages for power plant auxiliary. High efficiency, power factor correction, reliability and durability, precision control. High efficiency. Synchronized motor generally achieves 2 to 5% higher efficiency than comparable induction motor, especially at higher power output above 40 kW. This translates to significant energy saving over the motor lifetime. Power factor correction can operate at leading power factor, improving overall system power factors and reducing reactive power demand. This eliminate or reduces need for external capacitor banks, lowering energy cost. Reliability and durability. Robust construction with stable operation leads to 20 to 30% longer service life and reduced maintenance requirement. Critical for continuous power plant operation. Precision speed control. Essential for maintaining optimal operation condition in critical auxiliary speed accuracy within plus or minus 0.5 of rated speed. Implementation consideration. Starting process. Synchronous motors are not self-starting and require special methods to reach synchronous speed. Damper winding for induction start capability. Variable frequency for control to ramp up. Pony motor for very large installation. Excitation require DC excitation source for rotor field winding. Separate DC supply with slip rings, brushless excitation system, permanent magnet, helmet nails. Cost consideration. Historically, 50 to 30% initial cost cooperated to induction motor by typically efficiency gain and reduced maintenance within 2 to 5 years for high power applications. The future smarter and more efficiency. Advanced power electronics, wide bandgap semiconductor, enabling higher efficiency, faster switching, and reduced loss. Intelligent control, AI-driven algorithm for predictive control, adaptive tuning, and real-time optimization. Plant integration, seamless integration with plant-wide DCS and SCADA system for centralized monitoring and automation. Sustainability focus, enhance on energy efficiency reduction, carbon footprint, environmentally friendly operation. Conclusion. The indispensable role of synchronous drives for power plant auxiliary synchronous motor offers unparalleled reliability and precision. Modern control technology, including VFDs, advanced control algorithm integration with plants, wide system ensures they remain a vital component in their efficiency and safe operation of power generation facilities worldwide. Thank you.